Right, people? We are on our second topic, sequences and series. The marks for this is more or less 20. But this question can be quite difficult. So let's look at a few examples which will help you in the difficult problems also. Some will be easy, some will be quite difficult. I hope your hearts are very warm. It's very cold out here in Bloemfontein. And I'm sure where you are, it's also cold. But please, people, you must be so excited about the mathematics that you are doing that your hearts will be warm and therefore your bodies will also be warm. I also always said to my learners, you don't come into this class without a smile or a hop in your step, because mathematics is the most wonderful subject that you can get. So enjoy this topic. Let's start. Given the arithmetic series, 2 plus 9 plus 16 plus to 251 terms. The first question is quite easy. Write down the fourth term of the series. Now, people, the fourth term is the next term there. You don't need a formula for the nth term to find the fourth term. You can only look at this here and see that the difference there is 7. So you just have to add 7 there and your fourth term will be 23. Very simple, easy question. Then another easier one. Calculate the 251st term of the series. Before you can do that, you will have to find Tn. Because people, you cannot find or count from there to 250 terms. You will, somewhere along the road, make a mistake. And I once had a learner who did that. He counted a whole page for 251 terms. He got to the right answer. But people, I had to only give him half a mark because he didn't use the correct method. So the method here will be, first find the nth term. They say A is 2 and D is 7. And there is your formula. Tn is A plus n minus 1 D. Substitute your A and your D in there, and that's going to be 2 for A, 251 minus 1 there, and 7 for D. And if you calculate that, you've got calculators, people, you will get 1752. Remember this one because we are going to come back to this one just now. Okay. Then the next question. Express the series in sigma notation. Now, people, sigma notation is not difficult. Everybody thinks it's difficult to write a series into sigma notation. You only find the nth term in terms of n. So you take that and you simplify that. You can put the A in there, you can put the D in there, but the n should stay as it is. So there's your nth term. Let's simplify it. You're going to get 2 plus 7n plus minus 7d because g is 7. Right, people, then your nth term, Tn, is going to be 7n minus 5. Now, people, this is the term with which you can find any term in a sequence or a series, okay? So there you have it. And now you can say T51 in there also if you wanted to, and you will get the same answer because that will bring you to this formula. Right, let's go on. They said express the series in sigma notation. Right, so let's have a look. What did I do? This term, we started with n is 1. Let's have a look whether that is true. If n is 1, 7 times 1 is 7 minus 5, it gives you 2. So we started with n is 1, and we went up to 251 terms, because there it is. And next to the sigma, you only write 7n minus 5. What does this sigma actually mean to you? It means it's a formula for the sum of a series. We will get to something like that also. If they ask you to determine sigma, then you're going to determine the sum of this formula or this series. Okay. Right, let's have a look. 2.4. There they said, calculate the sum of the series. Aha. Sum of the series, you are going to use the sum formula, right? But in order to use the sum formula, you need your n, you need your d, you need your a. But you do have it. So you can immediately substitute all the values. You've got n there again, you've got a, you've got n minus 1, and you've got d, which is 7. And from there you can calculate the sum. Right, people? Now this is 125, 5, and this is giving you times that, and that will give you 220, 127. Very easy. People, if they give you sigma, and they ask you to determine, and they just give you that, you're also going to do the sum. But then you won't have the first 3 terms. So you won't have A, you won't have D. So you will have to find the first 3 terms so that you can have A and D and you've got N. And then you do exactly what we've did here. Right. 2.5. They said how many terms in this series are divisible by 4? Goodness gracious me, people. How many terms in this series are divisible by 4? I wrote down the series up to 44 because I realized 44 is also divisible by 4. So now I've actually got a new series or a new sequence. The first term will be 16, the next term will be 44, and the next term will be whatever. But 2 is enough because if I've got 2, I've got A, I've got D, which is 44 minus 16, and now I'm going to work with a new sequence there, that one. 16, 44, going on like that with a difference of 28, so the next term will be 72. So I will have D, I will have A, which is 16, and T251, if I go back there, I told you I'm going to go back there, is 1752. Let's see whether that is divisible by 4. 4 goes into 17 4 times, 3 times, 8 times. Yes. So your term 251, the last term, is also going to be divisible by 4. So our new sequence is 16, 44, 72, plus 28, plus 28, plus 28, and the last term in this sequence will be 1752 because there's only 251 terms. I hope you understand this, people. Right, it's not easy, but I hope if after today you will be able to do a similar problem. Really, people, mathematics can only be beaten if you sit down and do the sums yourselves. That's the only way to do math. Don't tell me that you were on your bed last night for 4 hours looking at your mathematics of the 2 terms. People, you will not be able to do well. You've got to sit up straight, take a pen and pencil, and take a book that you just keep for revision, and there you do your sums yourselves, and you make sure you can do it. People, I'm an old lady, I'm on pension already, and okay, it's 5 years since I've been really teaching. I've been mentoring teachers for 5 years. But people, I had to sit down for hours to look for these sums and to do them so that I can be sure that my explanation will be as simple as possible so that you people will understand it. So please, sit up straight, love to do it, tell yourself this is wonderful, and then you enjoy what you're doing. So this sum is specifically this one is a sum that you'll have to practice yourselves. Read the question, make sure that you know exactly what to do. Right, now I've got the first term, I've got D, and I've got that 1752. So now I can say, right, I've got Tn, which is 1752. It's the value of the last term. I've got A. I've got 1752 for the value of the last term. There it is. I've got A16. I've got 28. We are looking for n. Now, people, there's another thing that I want to emphasize. When you do sequences, when you do financial, write down everything that you have. There it is. Can you see? I've got it there. And then when I have to substitute, this is going to be so easy because T251 is going to be there. A is going to be 16. I don't know what the n here is, 28, because it's a new sequence. It's not that sequence any longer. The n is going to change because it's only every fourth term yet. Only every fourth term that will be divisible by 4. Right, there you have enough. If you've got 3 variables, you will be able to find the fourth one. 1, 2, 3. You always have to have 3 variables in order to use this formula. So if you don't have 3 variables, you will have to use another method, I'll show you just now, to find the third one before you can go back to your formula that was given to you for the nth term, for the sum, etc. Okay, now I can solve for n. I'm going to be 28n minus 28, and there I have 28n, and on this side 1752. 16 minus 28 gives me negative 12. 28n is, you take the 12 over there, it's 1764. Divided by 28 will give you n. So n is 63. People, n is not a whole number. There's something wrong. N should be a positive whole number or a natural number. But n can never be 0 or a negative. Have you got that? Very, very important. The n must be a positive natural number. Okay. Have you got this one? People, go home, treat yourself by doing it another time or more than once to make sure that you will recognize a sum like this. Have you got that? Right, people, let's go on to the next problem. Now I'm going to do a 1.4. No, people, I'm on the wrong sum here. Sorry. Where's my calculus? There it is. Right. The next calculus problem will be given the geometric sequence. Now, this is a very, very regular question. It's not difficult. There can be more difficult variable there. That could have been p plus 1, or if you understand that. But this is the method that I'm going to show you. And whenever you've got a variable in an equation or in a series or in a sequence, you've got to solve that variable. And to solve a variable, you need an equation. I told you just now also. You need an equation. That means you need something where you've got an equal sign. So now I'll have to find an equation from that. Now, what do you know about term 2 divided by term 1? It's going to give you r, because this is a quadratic equation. Can you see that? P divided by negative 11. What will that give you? R. So if I could put R equal to R, there's your difference. The difference there is minus 6. The difference there is negative 4. The difference there is negative 2. Why? Because I could see that it's a quadratic equation. So the first difference must have a plan or a rule. And the rule here is you add 2, you add 2. So I could write that there. But you could have done it in a different way also. You could have said, let me show you. You could have said T2 divided by T1 will give you T4 divided by T3. R is equal to R. But in this case, people, you can take this easier method, but most of the times, when there's a more difficult variable there, you must use this one. R is equal to R. Because we need an equation. But in this case, the second difference is going to be 2. You add 2 to each. Now we want P. So let's see how we can determine P from this knowledge. P minus 11 will be equal to negative 2. We saw that. But if you don't see that, then you use this method. You say R is equal to R. And you will get exactly the same answer. In this case, P plus 11 is negative 2. You bring the 11 to the right-hand side. And in the end, P is negative 13. Wonderful. Wonderful, people. But remember this method also. You've got to have an equation. So you put R equal to R. That's the actual method that you would use here. But this one was quite easy because we could see what's going to happen here. And we could determine that difference there by just looking at those two. Please, people, it's so important that you don't waste time in the exams. You've got to make sure that you keep on your time. If a sum is 4 marks, you only use 5 minutes for that sum, nothing more. If a sum is 2 marks, you can use 3 minutes. But if you can use 2 minutes, it's wonderful, so that you can go back to the more difficult sums and you have time for that, okay? So don't waste time on any sum. Rather go back later on. Right, the next one. Determine the nth term of this sequence. Now this is an geometric sequence. So what will the nth term look like? It's not a geometric, it's a quadratic. Sorry, it's a quadratic sequence, not a geometric sequence. And the nth term should look like that. Have you got it? If it was a geometric sequence, the nth term would have been Tn is a 1 minus r to the power n over 1 minus r. No, that is the sum. What is the nth term of a geometric sequence? Tn is a r n minus 1. And the sum of a geometric sequence is going to be a r to the power n minus 1 over r minus 1. You see, people, why I'm not writing here? Because I always write skew and ugly. But please remember that. It's a quadratic. But this should have been highlighted or underlined. And then if they want the nth term, that's what they want. Now, people, you've done this in grade 11. I'm going to rush through this one because it's not difficult. A, you've got formula with which you can determine your A, your B, and your C. For A, you say 2A is equal to the second difference there. So A is 1. Then for B, you say 3A plus B is equal to the first difference. It's negative 6. And then your A is already 2, so you've got 3 times 2 for A plus B. And then if you solve B, you will get B equal to, A is not 2, A is 1. I looked at that one. A is 1. So it's 3 plus B is negative 6. So B is going to be negative 6 minus 3, and it gives you negative 9. Have you got that? Sorry, we all make mistakes, nay, but try to make as little mistakes as possible in the exam. I would love to see a lot of distinctions at the end of the year. It will be the most wonderful thing that can happen to us in this project. Right, people, now you've got B. How do I determine C? A plus B plus C is equal to term 1. So you work upwards like that. To find A, you use that. To find B, you use that. To find C, you use that one. You've got A, you've got B, don't have C. A is 1, B is -9, and C you don't have, but that's equal to -1. We need an equation. People, can you see? There's always an equation when you want to solve a variable. Very, very important. And if I solve for C here, C is going to be -1 plus 9, which is 8, minus 1, which will give you 7, because you bring those two to the right-hand side. Then you complete your question by writing the equation, because the question was, determine the nth term of the sequence. Okay, people, the Tn is, A is 1, B is -9, and C is 7. There you have your nth term for this specific sequence. That is only a general form of the nth term. You cannot determine the sequence if you don't have A, B, or C. So you've got to find it, and that's the method that you will be using. People, every year there is a quadratic equation. Sometimes they will camouflage it a little bit, but please remember, somewhere you are going to find a quadratic equation. You're going to find these questions also, because they always have at least 2/3 of the paper easier questions. The other third is the problem, and that is where you want to improve on, because you want to be able to get a better symbol, at least a 6 or a 7, which will be wonderful for all of us. Right, 3.1.3. Let's read the question first. The first difference between two consecutive terms of a sequence is 96. Calculate the values of these two terms. Now, people, I would like to explain this consecutive terms to you. People, that means it's terms that follow one another, okay? So this is term 1. Now, term 2 will be term 1 plus D. Have you got that? Now, if I have plain common numbers, this is 9 and this is 10. How do I get to the 10? I'm going to say 9 plus 1. Right. If this is n, a consecutive term is only plus 1. The term plus 1. But that is values. So people, now if I have n terms, to get to the next term, it's going to be n plus 1. These are consecutive terms. These are values of terms. You're not interested in that now. You are interested in two consecutive terms, which is n plus n minus 1. Now, people, if they say two consecutive terms adds up to 96, then you are going to say n plus 1 is 96. You remember word sums, grade 8, 9, 10, where they said two consecutive numbers or three consecutive numbers adds up to 50. Right, people? The next question, the first difference between two consecutive terms of the sequence is 96. Now, what does consecutive terms mean? It means a term that follow one another. Term 1, term 2, term 3, term 4. But the value, how do I get from term 1 to term 2? It's term 1 plus the difference there. But term 1 has got a value, and term 2 has got a value, and D has got a value. But that is not consecutive terms. It's consecutive in the sequence. But if we work with numbers, two consecutive terms are 9 and 10. That means it's two numbers right next to one another. The one is one bigger than the other one. Now, people, to get to 10 from 9, if you only have 9, you're going to say 9 plus 1. Now, if you have n, how am I going to get to the next term? It's going to be n plus Those are two consecutive terms. Number 9, number 10. Number 7, number 8. Number 100, number 101. Okay. Now I've explained what a consecutive term is. So let's now go to this, back to the sum. We're going to say the difference between. This is the bigger one, this is the smaller one. That is 96. So now, what do they want you to find? Calculate the values of these two terms. Now let's have a look. We've got Tn. Tn is that one. So Tn is there, minus, and there's our Tn. Can you see I changed all those signs? Because I've been subtracting, okay? And then, for Tn plus 1, we also go there. And instead of n, we write n plus 1. There it is. N plus 1 square, 9n plus 7. Can you see what I did? I substituted the n plus 1 into Tn. Because it's the n that's changing. And that's all that's changing there. Right, and then I multiply all these and remove the brackets. You'll see that the 9n and the 9n will cancel. The 7 and the negative 7 will cancel. The n square will cancel. And all I have left, 2n minus 8. Where did I get that from? It's plus n, 1 minus 9 minus 7. And that will give me negative 8, negative 7. Why did I say negative 8 there? The 7's, oh, the 7's cancelled. Sorry. It's plus 1 minus 9. That gives me negative 8. So I'm quite right. I just didn't realize that the 7's also cancelled. Okay, people. And now I solve for n. 2n is 104. Therefore, n is going to be 52. But what was the question, people? You must always go back to the question and answer the question. They said the first difference between two consecutive terms of the sequence, I'm reading it to you, is 96. Calculate the values of these two terms. Now, if n is 52, what will n plus 1 be? N plus 1 will be 53. So now I'm going to determine the value of T52 by using my formula again, because that is Tn. 52 now is n. 52 is n. There's the 9 and there's the 7. And that is going to be giving me 2, 2, 4, 3. Then I'm going to determine T53. Why? Because it's n plus 1. T53, and if I determine T53, I'll also use that formula. That is the nth formula for this specific sequence. So now I'm going to substitute 53 into n, and I'm going to get 2339. And if I subtract those, I'm going to have 96. Is that what they wanted? Yes, that is what they wanted. They actually wanted the values of the two terms, and there they are. But I checked it by checking the difference, and the difference is definitely 96. Not so easy. Please make a point of it to see that you understand what consecutive means. Consecutive means term 9, term 10, but we're working with a 9 and a 10. So you just add 1 to get to the 10. And that is what we do when we do consecutive terms. I just want to write consecutive, I want to write consecutive there. And please, if you do this revision, make sure you know this one. There it is. Have you got it? Right, people, consecutive terms is only one added to the next, to find the next term. Right, let's go on to another question here. And that is going to be question 3.2. Question 3.2, we are given 16, 4, and 1, and they said to us it's geometric. Sometimes they don't say to us that we are working with a geometric sequence. Then we'll have to check ourselves. How do we check that? For an arithmetical sequence, we say T2 minus T1 should be equal to 2, 3 minus T2. For a geometric sequence, we say T2 divided by T1 should be equal to T3 divided by T2, which is, in this case, 4 over 16 is a quarter, 1 over 4 is a quarter. But in this case, they said to us it's geometric, so we didn't have to test whether it's geometric or arithmetical. But if they don't mention it, you will have to, on your own, see whether there's an R or a D. That's very easy, actually, because you can see it there. That's definitely not arithmetical, because the differences there are not the same. 3.2.1. Calculate the value of the 12th term. Very straightforward, easy. It is geometric. So to find the 12th term, there's our pattern or our sequence. There's R. A16R is a quarter. And that is actually 2 to the power negative 2. See, people, you write down what you have. And you ask yourself, what do I not have? I've got N also. So there I could have written N also. N is 12. If you have everything that was given right next to you, it's much easier to substitute into your equation there. So A is going to be 16. R is going to be 2 to the power negative 2 or 1 over 4. And your N minus 1 will be 12 minus 1. Have you got that? Right, people? Are you still smiling? Are you tired? No. You're young. So don't get tired. Please pay attention. Go for a walk if you're tired. Come back and start again looking at these questions. But let's concentrate, people. This is lovely. 12th term, 16. 2 to the power negative 2 times 11. So this was going to give you 2 to the power negative 22. It's 11 times 2. Why? Okay, I'll come back to that question there on the right-hand side. And this is going to give you 2, 4, plus that one is going to be negative 18, because this is negative and that is positive. So T12 is going to be 2 to the power negative 18, and that is going to be a half to the power 18. How did I get that? I swapped this fraction, 2 over 1. It becomes 1 over 2, and the exponent changed signs. It became positive there. I asked myself the question, why does this sequence converge? Now the answer there is R is a fraction. R is between negative 1 and positive 1. That is why this sequence converges. And then I said, calculate the sum of the sequence to infinity. There's your formula. Given. Make sure you know that this is the formula for the sum to infinity. People, the problem with most of you people, you don't know which formula to use where. Especially when you do financial and when you do sequences and series. Know your formula and know which formula is used in what kind of series. Okay. For an infinity series, we only use that. A is 16. R is 1 minus a quarter, and that gives us a 3/4. 16 divided by 3/4 will give you 16 times 4 over 3. You swap the 3/4 because of the division there. And that is going to give you 3/48 plus 16. It's times, it's not adding, it is 16 times. Oh, I made a little mistake here. So people, let's rectify it. You see, that is a very good thing that we are going through these sums so slowly. This is 16 times 4 over 3. So that will give you 64 times 4, which is 64, over 3. This part is the part that's not right. I actually made a common factor there because I thought that was a multiplication. People, we make these mistakes. And that's why the more we practice, the better we know how to do these. This is multiplication. So 16 times 4 over 3. My answer is correct. That step was definitely not needed there. Right, people? And that will give me 21,33 rounded, because it's an irrational number when you use your calculator for that one. It's going to be 21,3333, but you round it to 2 decimals there. Have you got that one, people? Very, very easy. Don't make a stupid mistake like I did there. The next question. Determine the value of that one. I actually want to close that at first. Look at this. You must times all these numbers. 1.5 times 1 1/3 times 1 over 1/4 times 1 over that. The next one will be times 1 over plus 1 over 6. Can you see that? Now the question here is, determine the value of this one up to 98 factors. Now this is definitely not a level 1 and 2 question, but it's actually very, very easy with a little few difficult parts in it. So let's have a look. I can do nothing with that because I want to do it up to 98 factors. So people, what I'm going to do, I'm going to find the values. This is 1.5, this is 1 1/3, this is 1 1/4, that is 1 and 1 over 5, okay? So this is, make it in proper fractions. 3 over 2, 4 over 3, 5 over 4, 6 over 5. Have you got that? Right. They said up to 98 factors. Now let's have a look, people. Can you see that this sequence actually started at the 3rd factor? Because you could have had here, you could have had 1 over 2, 2 over 2. And this is what makes this problem quite difficult. They say go up to 98 factors. But the first 2 factors here was not given in this one. So 98 factors only starts at term 3. So we'll have to go up to 100 factors to be able to have 98 numbers here. Difficult? Yes, it is. Because who would see that this should have been 2 over 2 and 1 over 2? So we only started at factor number 3. Difficult. Difficult to realize that. Please make sure you understand this, okay? I can actually write these 2 factors here in the red so that you know it's not part of this pattern. The pattern only started here, okay? This is only 2 terms that was left out. So when you go to 98 terms, you will actually get to term number 100. And if you look at this pattern here, it's going to be 1 plus, can you see, 100 over 99. There. 5 over 4, 6 over 5, 7 over 6, 8 over 7. And the last one will be 100 over 99. Not the plus there. I wrote it there so that I can confuse you people. This would have been written up there. And when you get the value of the term, it is 100 over 99. This would have been 1 plus 1 over 99. And then you just multiply that and you will get 100 over 99 for the last term. I hope you understand this. Because I just looked at that pattern and I decided that I must get to 100 there, not 98. And that will be over 99 according to that pattern. The previous one will be 99 over 98. The one before that would be 98 over 97. Right. To realize that it's 100 instead of 98 is not easy. But if you should write this out, you will see that 98 terms will give you that one as a last term. So now I must multiply all of those. People, look at how easy it is. Look at this. And you will go on like this up to the end. The 6 will be. So what is going to be left if you cancel right to the end? Only the 100 and the 2. So the value of this 98 factors is going to be 100 over 2. And that's going to be 50. Oh, I know what you're feeling like now. You're going to say, but how will we know that this is going to be the third term? You'll have to be wide awake. This is a sum for the sharper learners. And you are supposed to be the sharper learner. So, check it again and again until you understand what's going on here. This is the biggest problem, the fact that you'll have to go, because most of you would have gone to 98 over 99. People, we started at 3. We didn't start at number 1. That is why there's 2 terms short. That's why we have 100 there to make up for the 98 there. I hope if you go back to this sum, check it out very closely, you will be able to do it yourselves if you get something like that in your final exam. I also took questions from 2 IEB exam papers, not your papers. DOE, Department of Education, that is your papers. I took 2 of them, 2014 and March 2015, because I believe that you must rather go back to earlier question papers. They won't ask you the same question that they asked you last year. That I can promise you. It would rather be a typical question coming from an earlier paper. And then I took 2 question papers from the Independent Examination Board, IEP, different questions, so that you can meet with more different questions also. Because the DOE can use the IEP questions if they want to. So these 4 question papers are really 4 different question papers with different questions on them. I hope this will be of great help to you people. Let's go to question 3. In question 3 they said, consider the infinite geometric sequence. Okay, underline, infinite. Immediately if you see that, you're going to write R smaller than -1, R must be a fraction. Infinite, R must be a fraction. You've got the A there, but you don't have the R. So to find R, T2 divided by T1. And that is going to give you 0,9, which is 9 over 10. It's less than 1. So this is a geometric sequence that is infinite. Let's go on. Calculate the 12th term of the series. Now people, it's a geometric sequence. So to find the 12th term, you use your normal formula for the geometric sequence. Okay? And then you've got A, you've got R. They said create the value of, calculate the value of the 12th term. So you don't have the value of. People, T12 stands for the value of. 12 stands for the position of the term. Never ever forget that. So I want the value of the 12th term. A, R, n minus 1. And after I've calculated that, I got this, and I rounded it to 2 decimals, which will give me 14,12. Not so difficult, people. Actually very straightforward. Then 3.2. Explain why this is an infinite series. Now I said R is 0,9. Therefore R is between negative 1 and 1. It's a fraction. This is something that you must write down there already. Then this question is peanuts. Because people, if you see infinite geometric sequence, you remember R is a fraction. Please, please, please. Because with that knowledge, they can ask different questions. Let's have a look. Let's go to the next question, 3.3 there. Calculate the sum to infinity now. Sum to infinity is one of the easiest questions that they can ask you. That's your formula for sum to infinity. You know it by now. You put A there, you put R there. This gives you 0, 1, and 0, 1 divided into 45 will give you 450. And that is the sum to infinity. Have you got that? Let's go to question 3.4. Level 4 question, but actually not so difficult. What is the smallest value of n for the sum of infinity minus the sum Sn of the sequence smaller than 1? Now let's have a look. The sum to infinity we already have. It is 450. We determined it over here. Okay? We haven't determined the sum of the sequence. The sum of the sequence. And then we write the formula for the sum of that sequence. Smaller to 1. Because they said, find, let's go back to the question, n for this difference to be smaller than 1. Okay. So if you start there, you substitute, and then we find the sum of this up to n terms. We don't know what the n is going to be to give us a value smaller than 1. Right. So let's have a look. We don't have n, we do have r, and we have r there also. People, in this case, I could have used this formula actually. Because r is a fraction, you normally use this one. But I started using this one. It's not a problem. The only thing is you'll have negatives. In this case, you won't have negative underneath the line. But in this case, we are going to have one. It's not wrong. You can use this formula, people. So now we're going to have 450 minus 450 for that one, times 0, 9 to the power n. We do the distributive law here. We multiply like that. And then 45 times negative 1 is going to be, why 450? I divided it by that negative 1 already. So it's negative 450. Please, please remember that. Where I got that from, I took this negative 0, 1, I divided it into that one. And that gave me, if I multiply those two, it's 45 positive. Divide by negative 0, 1 gives you that. People, have you got that? I skipped a step there. Maybe I should just show you there again that how I got to that. It's negative 45. Oh, my left hand. Negative 45 times negative 1. Negative 1 divided by negative 0, 1. And this is going to give me 450. Sorry, people, for that one. But if you go through these sums again and you sit there, you won't understand where I got that from. That is where I got it from. Ugly, but it's there. Right. And this is going to be 450 minus 450, gone. And we left with that smaller than 1. Now we're sitting here with a problem. Because now I'm taking away the 450 there. Oh, but how will I solve n there? I hope you know. I hope you know. This is in exponential form. It's impossible to find n in this case by using exponents. So the easiest way to do this is to rewrite this into log form. People, to find n, yeah, the only easy method is rewrite this into log form. So if you cannot solve an exponential equation, you rewrite it into log form. And to rewrite that into log form, you put a log there, you put a log there. This n is the exponent, so you can take the n to the front there. And then you divide by that on both sides. So n is going to be that. But people, can you see something that happened here? The inequality was smaller than. The moment I divided by a log, which is a fraction, we swap this inequality. If it's not a fraction there, you don't swap the inequality, okay? So this is definitely a level 4 problem. Can you see it? Please, if you see these sums, go over it again and again. Write down the sum and try it yourselves also, okay? Because if you write, you remember. If you write a second time, you remember more. And by the third time, you will remember it most definitely. So make sure you understand what I did here. The n must be larger than this. Now, when I did this on my calculator, I got that answer. What is the next whole number after 57,9? It is 58, because they said the smallest number for n. N cannot be a fraction. So the smallest one, it's the one just after 57,9. It's going to be 58. It cannot be 57 because there's a larger than there. Okay, so the next one after 57,9 is 58. People, a lacquer difficult sum for you. Make sure you can do it. Okay, let's go to the next one. I'm doing quite a few examples on patterns, sequences, and series. Why? Because people, it's very, very important to me that you will be able to do the difficult ones. I redid that one here again with big spaces. I want you to look at it just so that you don't get confused. So maybe if you look at the second one I did it, or the second time I did it, you will understand more. Oh yes, there I wrote everything, because I realized after I did it, I must redo it for myself to understand it very, very well. And that is that sum. So please, go back and check this sum again. There it is, from beginning up to the end. Written very large, written so that you will understand. Good luck with that one and enjoy it. Have a smile on your dial all the time. Please, please, please. This is wonderful. And the moment you understand, it is even more wonderful. Okay, the next one is this one. Let's have a look at it. If you look at this sum, they said calculate. Now, I told you just now, you don't have, it's arithmetical because there's no exponent there. You don't have D, you have N. That's all you have. So you will have to do something else before you can determine the sum. If they say calculate, they want you to determine the sum of the sequence. Okay, but now we need the variables. So we're going to use this because this is the nth term of this specific sum. And we're going to start with substituting n because n starts at 1. And instead of k, you write a 1. And that is what you get. So your first term is going to be 97. Your second term will be 100 minus 3 times 2, it's 94. The third term, go to the third term, because maybe you made a mistake somewhere, and if you only use these two terms, the mistake will go through the whole sum. So work out your third term also. 100 minus 3 times 3 is 91. So you see now clearly that this is an arithmetical sequence, or series in this case, because we want to find the sum. A is 97, and the difference is negative 3. 97 minus 94, negative 3. Or 3. What did I add to get there? A negative 3. 94 to 91, I added a negative 3 to get to the next term. Okay. So now you have A, you have D, and you have N. What is N? In this case, it's 50. People, it's always the number on top minus the number at the bottom plus 1. And your N, in this case, is going to be 50. Now people say, for instance, they started with a 3 there. Then it's going to be 50 minus 3 is 47, plus 1 is 48. Then your N would have been 48. In this case, straightforward, the N is actually that number. But always, always check what they gave there. If it's 1, it's fine. But if there's another number there, you use that formula to get to your N. Okay. Now they said, calculate this. Now sigma means the sum of. So now we've got all our information, and now we're going to determine sum by using our sum formula. People, these formulas, the Tn formula, the sum formula, the Tn for geometric, the sum for geometric, they will all be on your formula sheet. The problem is, you must remember where there's a D, it's always arithmetical. Where there's a R, it's always geometrical. And they won't say Tn or Sn, they will only give the formula there. Maybe they will be lenient and they will put Tn and Sn there. But then you remember, this is the formula for the sum of an arithmetical sequence. You substitute all your values, and then you calculate with your camera, and this gave me 1175. Okay, have you got that one? Straightforward. Level 1, level 2. Actually level 2 because of the fact that it's sigma. Right, people, let's look at point 2.3. I've got a lot of examples here in the sequences and series, although it's not a lot of marks. But people, they can ask you such a lot of different things. So I'm really taking my time with your sequences and series so that you meet with a lot of different things. Right, let's have a look at this one. A quadratic sequence is defined with the following properties. T2 minus T1 is 7, 2, 3. Can you see that? Right, but what do you immediately realize here? This is the first difference of the quadratic, because it's quadratic. The second difference will now be 13 minus 7 is 6, 19 minus 13 is 6. But that is this one is your first difference. So please, people, the difference here is a constant number 6. Can you see that? So this forms a pattern also, a sequence. And this is an arithmetical sequence. And when I started with this sum, I said to myself, wow, maybe I must immediately find Tn for this first difference. So I did it quickly, because the difference is 6, and to get to 7 you add 1. That is for term 1. So I immediately did that. But later on in the sum, we actually needed it. So wonderful if you can see something like that. Do it immediately, and then you've got it already. Okay. Now the first question here, write down the value of T5 minus T4. Now let's have a look. T5 minus T4. I immediately wrote the answer. Why? Because if you look at this, the difference there is 6. So if I add T5 minus T4, the difference there will be 25. You just add the 6 there. Okay. Write down the value of the following. T70 minus T69. Oh, golly, people, now it's not going to be so easy, because you'll have to count up to there unless you've got another method, and there is another method. We're not going to count. Okay. T70 minus T69. I wrote down this first difference there. Then I wrote down the second difference there. We still don't know what the pattern there should look like. The initial sequence. So we're going to write down the first difference and the second difference. And then from there, people, we'll see, we actually know now that T4 is 25, and we wrote it in there. So T5 will be 31 if you add 6. But 4 terms there is more than enough, okay? So now we've got the second difference also. But this is the question. So let's have a look what we can do about this. 2.3.1b. Calculate the value, no, that is 2.2. Let's first go to that one, 2.3.1, T70 minus T69. Now, if we look at this pattern here of the first difference, we're going to say A is 7, D is 6. Because I wrote it there already, but I actually worked it out again here to show you where I got that from. It's the nth term of an arithmetical sequence. So it's A plus n minus 1d, and we got 1 plus 6n there. Have you got that one? Right, people. So we know now that A is 7 and D is 6. So now, T70 minus T69 will be 7 plus that last term, minus 1 times 6. I'll explain that to you just now. And we got 415. Now, people, how did I know to substitute the last term in here to find the difference here? Now, let's have a look. If you look at this, T1 is actually 7. T2, 6 plus 12 is 13. T3, 1 plus 18 is 19. You see where I got it from? So when you do this difference, you use this term to find the value of the difference between them. Can you see that? Wow, not so easy to realize that. Definitely a level 4 question here, because you had to see a lot of things. The next one is actually more difficult. Let's have a look at the question. 2.3.2. Calculate the value of T69 if T89 is that. This is only the difference between two terms. Now they want the value of T69. Now let's have a look what we're going to do here. The first thing, we've got to realize that the formula for Tn of this quadratic sequence here is an squared plus bn plus c. But we don't have it because we don't have the first row of this sequence. It should be in here. Can you see that? There. Okay. We don't have it. So we'll have to make a plan now. We know that Tn is in that form. We know that T89 is this. So now I can go to that formula. I can say T89 is 3 for A. 89 squared. Where did I get the A from? I said 2A is 6. A is 3. I can also determine B by using that. 3A plus B is 7. So B is 9 plus B is 7. B is negative 2. But we can't find C because we don't have the actual sequence there on top. Can you see that? There should be another row there which is the actual given sequence. This was the first difference and this was the second difference. Have you got it? Right, people. But now they gave us T89. If they give you something, you are supposed to use it. So you must use it. And then I could, by substituting 89 in there, I could find C. Wonderful. Now I've got the equation of my quadratic equation, the equation for this specific one. Instead of A, we write 3. Instead of B, -2. Instead of C, it's 9. So if I want to determine the value of T69, there's my A, there's my N. There's my B, there's my N, there's my C. Can you see? Everything came from there. Right, then you take your calculator, and people, this is the value of T69. Wonderful. Difficult. Make sure you understand what we did. Okay. Thank you, people. Let's go on to the almost last question for sequences and series. There it is, another funny question. Let's have a look. They gave this sequence to us. Oh, immediately you get a shock because what kind of sequence is this? Can this be 2 sequences? Now, people, a very easy method. You can actually calculate this. You can calculate this. This is going to be 8 minus 1, which is 7. This one is going to be 27 minus 1 divided by 2, 13. This one is going to be 64 minus 1 divided by 3, 21. 125 minus 1 divided by 4 gives you 31. So there, you could actually write down the pattern. And I would have done that, most definitely. So let's look at my method, and then I'll show you another method, which is also going to give me the same answer. Calculate the terms and use the old method. Now, what is the old method for a sequence like this? 7 plus 6 is 13. 13 plus 8 is 21. 21 plus 10 is 31. They never mentioned quadratic. Can you see that? So you must realize that this is a quadratic equation because the terms differ not by the same number. You cannot make it a geometric sequence, so there will be a second difference. And the second difference, I actually wrote down the 4 terms there for you again. And from there, I wrote the second difference. 13 minus 7, 6. 8, 10. Can you see that? Wonderful. So, there's a second difference also. That's the first difference. It's right there. First difference, second difference. Second difference is going to be 2. So now we actually prove to ourselves that this is a quadratic equation. So what are we going to do now? We're going to find A, B, and C. Old method, I'm going to do it quickly because this is now very easy. You've got all 3 of them there. The actual sequence, first difference, second difference. 2A is 2, so A is 1. 3A plus B is 6, so B is 3. A plus B plus C is 7, so C is 3. Old method, straightforward method. So the actual nth term of this sequence will be A squared plus 3n plus 3. And this is the method that I would really recommend you to do. Okay? Because if you could realize that, but you can calculate this, you actually have a straightforward pattern. Right. Let's go do the other method. I just want to show it to you because some of you are going to say to me, but if I did this, would this be right? Now let's see. T1 of Tn rather is going to be, look at this. This is 2. So to get from n to 2, n is always starts at 1. So you're going to say n plus 1 to find the 2. To the power 3 minus 1 over n. Because in this case, n is 1. 1 plus 1 is 2. The n is 1. So you could have used that formula, giving the terms an n formula, a Tn formula. Not very difficult, but it's going to be difficult for a lot of you. So I'd rather do that method. And then if you've done that, look at this. You remove the brackets, you get that. You take out n as a common factor, you cancel. And voila, look at this. It's a way shorter method. But it's difficult to realize that I've got to put n's in there to find the nth term. Nobody told you to find the nth term ever like this. You always use this method. So you can make a decision to use the first method, or if you think you can do the second method and you can do it, you do it. It's quicker, but it's seldom that you can do this method. It's only because there's only numbers there. Can you see that? Right, people? I hope you understood that one. Now let's go on to question 5. They gave this. Now I did this one just to show you how simple it can be. Look at this. They said determine y, the n, eh? Now people, the sum is 36. You can do this. It's sigma. You'll have to find the first 3 terms first. And the first 3 terms is 7, 17, and 5 plus is 15 plus 2 is 17. 5 times 1 is 7. Term 1 and term 3. That is what we got there. It's an arithmetical sequence because there's no exponents there. And there's term 2. 5 times 2. So we've got 1, 2, and 3. There's your sequence. 7, 12, 17. I realized it's arithmetical. I wrote it there. Do it, people. Because if you see arithmetical, you'll know which formula to use in this sum. Okay? Right, there's your first 3 terms. So now you have A. A is going to be 7. You've got D, because D is going to be 12 minus 7, which is 5. 17 minus 12, 5. You've got the value of the sum. And now you've got to find y, n in our language. Now, so you've got to find that y. So it's sum. So you're going to go through the long way, and you're going to say, use that formula, and you will get a value for n. But look at this. You've only got a very small sum there. 7 plus 12 is 19, plus 17 is 36. So what is the value of that y? 3. It's the sum of the first 3 terms. Now, if you use that formula, you've got information enough to do that. Your n will also be 3. And that n is actually the y there. Because remember, we normally work with an n there. But they tried to confuse you, and they put a y there. But the sum is so small, so what I did, I added the 3 terms, I got the 36, and I realized that is the sum of 3 terms. So the y there is going to be 3. Very simple, very easy. I actually wrote here, look for a shorter method. Time is very, very important. People, time is your enemy when you write mathematics. Because if you give me 5 hours to do paper 1, if I give you 5 hours, you will actually get much better marks than 3 hours doing the whole paper. But now you only got 3 hours, so where you can take a shorter method, do it. I'm just showing you, if the sum is small, then you must realize, maybe there's a better method or a shorter method to do this. Okay, right, let's go to the next page. And the next sum is number B. An arithmetical sequence is given as this. This is a very easy question if you know what to do. I just thought I must do everything possible that you can get in the exams. If you must determine a value of any variable, you must have an equation. You need an equation. So now people, they want you to find P. That's the first question, determine P. So you need an equation. And because you realize, or they said that this is arithmetical, you're going to write this, you're going to say, arithmetical, for my equation, I'm going to put D equal to D. Geometrical, R equal to R. Remember that, please. Okay, so D is going to be T2 minus T1, T3 minus T2. Be careful for your signs. If there's a negative, you must put the whole term there in brackets so that you can remove the brackets in the next step. So I removed all the brackets and I got P minus 14 here, minus 2P. Here I have minus 2P plus 7. I forgot the 2P there. Let me quickly write it in there. 3, no, I didn't. I just skipped a step. Sorry. 3P minus 2P gives me P minus 14. Okay. I mustn't do that. You might multiply the negative with that term and that term, not the 3P, people. Okay? Right. Then I solve for P and P is equal to 7. That's not so difficult. But please realize that you need an equation. You cannot just solve for P. Okay, let's go to the next one, the last sum. There I actually wrote to you to remind you, if it's a geometric sequence, to find the equation, you put R equal to R. The next one, and that is what you do if you find R equal to R. Just a little hint that I wrote there for you so that you will remember it if they give you a geometric question. Right, let's have a look at the next one. The next question, D. The sum of the first n terms of a geometric series, now it's geometric, ne? Is 9 plus 6 plus 4 is greater than 25. Calculate the smallest value of n. We had a similar sum just now. It was just more difficult than this one. Because in this one you've got A. You know that R is T2 divided by T1. And you've got the sum. What do they want to know? They want to find n. So n is the one that you should be able to find now by using the sum formula. They said sum, so you use the sum formula. Please, please choose the correct formula. And then all you do is substitute. There you will have, your sum must be larger than 25. So you're going to say sum is 25, and the actual sum must be larger than 25. So I want to find that in. My n is very low down. It should be on top there, people. Please make sure that you don't make writing mistakes like that. There I rectified it. 25 smaller than that. 1 minus r. 1 minus 2 over 3 gives me 1 over 3. Then I multiply by 3 over 1 to get rid of this. You swap it and you multiply the whole equation by that. And if I multiply 25 by 3 over 1, no, I don't have to do that. I can only remove the bracket here. And that will give me 27, 1 minus 2 over 3 to the power n. And there you still have your 25. Now, people, I'm sitting here with a stupid equation where I have exponents. I simplified this, 27 minus 27 times that. Then I divide it by the 27 so that I can only have 1. Only 1. That's all you need if you want to take this to logs. You cannot have the 27 together with that. You've only got to have one term there with the exponent, nothing extra. Okay, so now you've got that exponent there and you've got a value there. Only now you can rewrite from exponential form to log form. Use logs now. The log of that, I swapped it because it's easier to that. I shouldn't have changed that there now. I should change it only when I get here. Okay, log 2 over 3 to the power n, log 2 over 27. You just put logs in front of these two numbers here. Then you divide by the log, this log into that log, or no, this log divided by that log will give you n. I'll come back to the inequalities there now. Okay? The moment you divide by a fraction there, the inequality changes. So that inequality should still look like that. Why? Have a look. The 2/3 is at the open little mouth of my inequality. Can you see it? And I swapped it, so I should swap the inequality there. But the moment I divide by a log with a fraction on that side, I will again swap. Now only I will swap that inequality. People, this is not easy to remember. Because normally you only swap when you have a negative on the left-hand side. But now I swap because there's a fraction there. So this becomes n. I divide by that one there. I determine this with my calculator, and I get n larger than that. What is the smallest whole number after 6,4? It is 7. You have it? Go over it again and again and again, because this is quite confusing, okay? And you see, because I went there and I made logs, I changed that inequality, and I never realized you only change the moment you divide by that log with a fraction. Okay, right, people, I think we've done quite a lot on sequences and series. I just want to give you a few things that you must remember. It's not sums, it's just a few things that I didn't pick up in these sums. If they say T4 minus T100, you're going to say A plus 99D minus A plus 3D. Can you see that? If they say this is a geometric sequence, T100 minus T4, you're going to no. Then if it's geometric, you will put T100 over T4, and that is going to give you AR 96. Can you see that? So please, if they give you two terms that is quite far from one another, you must use this knowledge. Don't forget it, okay? And then there's another thing that I didn't pick up in these sums. If they say determine, this is a pattern or a series, determine S10 minus S9. What are you going to do there? Now, people, if you think about a series and you've got, say, for instance, your S10 was 21 and your S9 was 16. You will subtract these two and you will get 5. Now, what are we going to do? That is the values. So this is Tn that you used here. So you're going to find the value of T10 and the value of T9 by using the Tn formula. Because the difference between those terms will give you whatever they wanted here. They wanted to know what is the difference between that. If I have the sum of term 9 up to 16, and the sum of the terms up to term 10 is 21, the difference there is actually going to be the value of your T10 minus T9. Have you got that? This was not in those sums, not in one of those papers, but I realized that I must show you this also. Okay. Then subtract, and that will give you S10 minus S9. I'm sure you did these sums in class also. But if you go and do revision, people, if you take this revision, people, I've done everything possible for sequences and series. So please make sure you can do it. Oh, there's another sum that I'm thinking of, but it's fine. You will be able to do your sums in sequences and series if you take note of all these sums that I did. Thank you, people. This is the end of sequences and series.